I'm doing good. Exams are over. Ooh, awesome. Well, I definitely on semester 2 now. Oh, that's quick. I feel like you barely even got a break. I can make sure things are going good. You feel the same? Yeah, okay. Well, I won't like hound you for it, but once you do have time, I'm definitely still interested in surf. Oh, I never got the music started. Let's do that. But obviously your school takes more importance. There we go. Okay, I think I'm set to go. Just making sure things are okay over on YouTube, and it looks like they are. All right, let's get into it. They're going hard at uni? Oh, okay. Let's see what my DMs are. How close are you to, like, graduating? It seems like you're doing some pretty, like, fancy math. Three years? Oh my god. It's only going to get harder from here? Been at uni for... Oh my god! I thought you were at least a year in or something. I didn't realize that was like your first semester when we were like working on questions like late last year. Or whatever, like quarter. I don't know how things work over there, but called Basic Math 1. Oh my god. I can't even imagine what you're going to be doing towards the end of your degree then. Since he was on your... Oh yeah, that's right. And you said that you were likely going to be good at that because you already wrote the paper on it for your A level. Okay, so we're just adding on to what I said. So there's a chi-square distribution problem. This person was saying they can use Excel because the person had a chi-square value that was off the chart that they had. This person is saying they can use Excel to get the actual value, which is completely true. Or, I mean, I bet it's true. I haven't used Excel to get chi-square exactly, but I'm sure there's a function for it somewhere. In this one, they had this piecewise linear function. They had to basically take this, transform it into this. This little -3 they had in their answer was a bit wrong because -3 is a vertical shift, but you actually want a vertical shrink. And that's what I said, and they said, thank you for... Okay, good. All right, so nothing new for us to respond to. Let's go to the usual. How much on this subreddit? At the top one? Professor Leonard for Calc 3, but shorter? Oh. Oh god, they have an essay? I never heard of Miller's algorithm. Do you know, or are you just saying because it looks hard? Because it looks hard? Oh, good. Well, I definitely have no idea what's happening here. An elliptic curve point P of order 15? Maybe I don't know what an elliptic curve is either. I was just imagining an ellipse, but I think this is something more advanced. Yeah, I have no clue. It's one that I can actually do. Fourth grade math. Let's see. Elliptic curve. I've seen these just because they happen to come up. A certain type of cubic equation with two variables. Oh, go away. Oh, it's with y squared equals some cubic. Yeah, I have some interesting looking graphs there. Like a capital omega. All right, but fourth grade math sounds a bit more my speed. Let's see what's up with this. Oh no, this doesn't even look my speed. What the heck is this? Flipping a card and shading the diagram to represent the number on the card. The first person to fill the diagram wins? Does 0.6 mean you fill in 60% of the squares? This feels a little vague. I have no, you know what? It's apparently I need to go down to third grade math or something because this is I have no clue what's happening with this question. Oh wait, there's a comment. Let's see what the comment is. Pick those cards to somewhat be equal to 1. I guess so. Just gonna leave that one be. C10. This is square and triangles are equal. That's a square. Triangles are equal. C10? That's a little too zoomed in. Well, maybe I'm not a little zoom. C10. No, C10. Oh my god. Can I have a simple question? What is this? So I guess we can notice that MC10 is similar to MNS. So NS is 2, which would correspond with C10. So if we can figure out the proportion between the small triangle and the big triangle, we're home free. And actually, wait, we have so much extra information here? No. If we extended the C10 line down here, we don't know what this length is necessarily. We just don't know what it is. At least not right now. I was hoping that we'd be given a bunch of extra information here and we actually just distill it down to the similar triangle thing and we're home free, but I don't think so. What are they trying to do here? A1, D1. Where's D1? Hey, hoo-hoo. My favorite Frenchie is indeed here. Yeah, bonjour. Baguette. Croissant. Bonjour, don don. Let's just talk like that from now on. My fake French accent. You ate fake croissant yesterday. Why was it fake? Was it like store-bought or something? Oh, okay. Over here, that's about as real as croissants get, so... I mean, you can get like fresh baked croissants, but I'm sure they're like not quite the same as over there. Excuse me. I don't know what's happening to this sheet geometry question. I'm gonna move on. Well, how was your fake croissant? Not too offensive, I hope. Misspelling the word English on an English question feels kind of bad. You don't really like fresh? You like the fake one more, really? Are the French police gonna try and like hunt you down now for saying that? It's better. Like meow. Yeah, I forgot about that. Meow. Fair enough. Please no trig. Oh gosh. I did take a class in this, but I don't think I wish I knew their list of like propositions and stuff and axioms. I probably find one, but well, I guess they did say Euclidean geometry, which basically should tell you, but I don't remember it well off the top of my head. Hmm. Wait, so which part are they asking about exactly here? They're only true if the second derivative exists, in bold. Hence, they are not valid definitions of the second derivative. Okay, and so what are they asking about? Oh, good. You got the actual first redeem bin, so that way it's solidified in history. Glad you made it. Yeah, glad to have you. First chat, yeah. It's a pretty elite group of people who have gone first. It seems like it's more telling you to avoid a fallacy, is my interpretation of the language here. Well, I mean, okay. Um, Conditions for existence of derivative. Mm. So let's refresh again. I think I feel confident to give an answer to this person. I'm not going to be completely confident in it, but I'll put some caveats in here. I interpret it more or less the same way as you do. It sounds like formulas provided. Or it sounds like it's more of a, this is interesting, but don't use it type of thing. You could somehow prove that the derivative exists because it's continuous and has no sharp corners, then sure, I guess, or the second exists because the first derivative is continuous and has no, then sure, I guess the formulas would work. Gonna get some sleep? All right, Ben. Thanks for saying hi, and good luck with your classes. All right, I think that's enough that. Yeah, so it seems like they're interpreting it correctly, at least from how I read it. All right, sleep well, Ben. Okay, yeah, that fourth grade math question got help. Um, So that's where I just was. Okay, differential equations. I got to click on it. Let's see if it has an answer. It does. Wow. Oh. That's clever. taking x as the dependent variable, basically doing x as a function of y. Wow, okay. I did not even, like, I know, I'm glad I read this post, because like, this is a neat trick. So yeah, the x's are way simpler than the y's, and so you can definitely get this in a normal form for a first order linear equation in terms of x. Well, for x in terms of y. Okay, logarithmic differentiation. It does have an answer though. Let's go over to learn math. To roll consecutive numbers. Why isn't this 1/6 to the power of 5? Oh, because, well, if you're doing 5 dice simultaneously and you rearrange them, I don't know. Yeah, I don't like probability. Okay, they're given this and they have to simplify it. I don't know what TIA is, but are you just asking to verify these answers? I guess we can do that. So let's look at the constants first. We get 27 minus 21 it should be, our constant term should be 6. I think they did 27 plus 21. Okay, for the x terms, we have negative 18 plus 3 is negative 15. I don't know how they get the positive 3. Did they get the y one? Let's see, they get 45y minus 3 times a negative 2. Oh, shoot. I think we might need to draw this one out. Maybe draw all these out. So I can really explain. I think we got all 3 of the terms wrong here, and it's going to be hard to correct this in text. Well, I think I actually could. Let's see how we do on the other ones, though. So let's look at the A's. We have a 1A here, minus 27A is minus 26A. That's good. Let's look at our B's. We have a minus 4B plus 9B is, okay, yeah, so it should be positive 5B. And our c's, minus 20c plus 2c is minus 18c. Okay, so this one, they got two out of 3. And then for this one, our x is, oh, they write y first. So we have a minus 5y minus 4y. Well, there's another minus sign though. So it's a minus 4y minus is plus 4y minus 5y. So it should just be minus y, I think. So that should, the sign on that should be flipped. Look at the x's. We have a negative x minus 2x is positive 1x. Good. Constant terms, we have a minus 2 times minus 5 is plus 10. So they flip the sign on the 10. Which kind of pain is the most annoying? It's a good question. I feel like it's whatever type of pain I'm currently experiencing is my real answer, but like back pain, like actually like just last night I slept funny and my neck has been like hurting a little bit all day. Which is annoying. There's no type of pain. I don't think it's a type of pain that I like. Maybe I need to experiment more. I don't know. Headaches are really annoying too. It's like you just can't even think. Let's actually check. So I'm about to say all their answers are off, but I didn't actually check this last one. So this is just normal arithmetic. So we have 4 times 2 times 2. 16. Minus 12 is 4. Plus 9. It's 13 over 3? I don't know how they got 37 out of that. This is 12 divided by 3. It's its own unit. But even then, I think we're probably off. I don't know. You actually like headaches? Oh, relative to other pains. Okay, I was like, you need some justification for that statement. Really? I don't know, man. Headaches suck. Like, I feel like I can't even think when I have one. Oh, ear pain. Okay, yeah. A toothache or whatever. I haven't had one, thank God, but that sounds like that's one of the worst ones that you could have. I did have an ear infection as a kid, and that was definitely not fun. Just lie down and chill. It's not chilling for me. Partially agree with. A common pattern in these, or a common mistake you're making here is with the signs. For the first one, if I expand everything out, it becomes 27 minus 18x. Let's space things out like how they did it. Plus 45y minus, or plus 3x minus 21 plus 6y, which then becomes 6 minus 15x plus 51y. Feeling before you have to puke. Dude, honestly, with some exceptions, the feeling before you puke is almost worse than the puking. I hate it. Like, it's just like the anticipation. Just like, or like that feeling of knowing that you're about to puke. It's the absolute worst. I don't know. I don't think, is there a word in that for German? Because I don't think there's an English word besides just like describing it like how you just did. Use almost relief. Yeah, exactly. It's like I normally feel better after I puke. It's called Ubulki. I need to hear a pronunciation of that. Of course, I already knew that. I was just quizzing you. Nausea. Oh, okay, yeah. We have a word for nausea, or we have a word for nausea, and it's nausea. I guess yeah. There is that. Übelkeit. Okay. I don't think the audio went through on stream because I don't have this browser being piped through my OBS, but Übelkeit. I guess I always thought nausea is something slightly different, but that really is nausea. For pronunciation, I know, because I'm fluent in German. Thank you. Let's give them Wolfram Alpha as a resource here too. Three minus 2x plus 5y minus 3 minus x plus 7 minus 2y. Minus 15x plus 51y. Yeah, plus 6. Oh, thank you for wishing my back well. I need to remember to like sit up straight. It was a lot worse this morning. I can still feel it a little bit, but it doesn't hurt nearly as much. So they did 27 plus 21 rather than 27 minus 21, for example. Are similar errors on the others. Can help more if you want, but not sure if you wanted to work it out for yourself. As a side note, there is a site called Wolfram Alpha that can do this for you, or that can help you check your work. Here is where I input your first problem. For an example, you scroll down a bit, it provides the answer in the format. Okay. Back pain's also annoying. Time passing your body growing old? Yeah. All right, I got 2 DMs. Oh gosh, this person, they like replying. Oh, smartest when you're 25 years old? Oh. So if I'm 26, it's just all like downhill. Well, I know, because like if you're a kid, you learn things so much quicker though. I've heard that your brain finishes developing at 25. Well, okay, I guess it depends on how you're defining smart, because like little kid me was really stupid, but little kid me could also learn certain things a lot quicker. Kids definitely learn the fast. I think, yeah. Let me put my mug away. I'm out of tea. Zach, thank you very much for the raid. Yo, too. Oh, I was wondering where you were going with that. I, you, he, she, you. Hey, Obi. Nosotros, yeah. In vosotros, if you're Spanish, apparently. Or ellas, ellos as well. Ustedes. I think that those are all the pronouns. I think the reason you tend to get dumber after 20 bits because you learn a lot less. Yeah. Pushing so many languages. Yeah, I know, Spectre. I'm just it's the word like polyglot. Or so someone who knows like every language. I forgot who was talking about Lena. It might have been standard C out. I remember Dan was commenting on it, but I don't think he's the one who brought it up. Yeah, yeah. See, I was working on, I replied to this person who was asking about a formula for the second derivative. That apparently it doesn't, it only works if the second derivative exists, so they're actually not, apparently not all that helpful. Because you already know the second derivative exists, and you probably have found it a different way, but this person so I said, like, it's more like an interesting thing as far as I'm interpreting it, but not something you should actually use. It's clearly correct. But they replied back to me and said that apparently this can be used in numerical methods, which makes sense. Because numerical methods, you don't really care about being rigorous about things. And I imagine this is more or less an extension of instead of making a tangent line, or a secant line rather, that approaches a tangent line, you're making like some kind of like parabola or something to measure the concavity if you're talking about a second derivative. I don't know exactly how to interpret the numerator there, but that's how it seems to me. Maybe it's more like you're making, I guess it's like you're making two different secant lines that almost behave like a parabola. Truth me up, you have, okay, so I do need to figure out what exactly they're asking me though. Okay, so this is the first comment, it looks like. This is the stack exchange thing with discussion. Notice that f must be differentiable in an open interval around x, which is critical for L'Hopital's to work, but f prime need not be differentiable or even continuous in an open interval around x. Can you be differentiable at a single point and at no other point around that? What's the stack exchange link saying, I guess? Numerical methods is not theoretical. Oh, well, I know it's based in theory, but like, I'm saying that like, if you don't have to be all like, you can just look at a graph and say, oh yeah, this has a second derivative, rather than having to actually like prove it. No, I did take a numerical methods class because that's one of the classes I took specifically to avoid proofs, but it still gets pretty in the weeds with different algorithms that do the same thing but in different ways, and learning all the different ways that you can answer or you can get approximations to like difficult questions. The numerical methods book instead of a mathematical methods book. Oh no. I mean, I enjoyed the numerical methods class that I took. I remember hardly any of it, but we were coding in MATLAB, and it was only me and one other student because it was required for our major to be able to graduate. But the major was very small, so we ended up having a class with 2 people. Let's see what that is. In college. Oh, okay. Typing in -202, -0, order 2. Oh. Yeah. I don't know where the 4 comes from. I'm sure it comes from somewhere, though. Huh. For like not much. We just left the rest of it for another day. We got like half of an NBC suit. We're gonna continue it some other time. So this person asking about this last note here, and the open interval thing is just a consequence of L'Hopital's. I wonder why they're getting stuck on that, because I would just accept that as true without really questioning, but they're asking. F prime not need be differentiable or even continuous in an open interval around x. Yeah, I'm confused at that too, Zach, because you need to worry about the area around X. From my understanding. Spoiler for later. Okay. That's fair. You have many secrets, I know. The single point X. I'm trying to engineer some function that will be differentiable at one point, but not the point right next to it on either side. But it seems a little hard. Hmm. Okay, so I kind of want to draw on the board how I'm interpreting this, because I might need to send a screenshot to this person. Because I want to take the second form that's given and break it up into two pieces. So I'm just going to rewrite the second formula as it was given in the book. F of x plus h. That's not f of x. Why can I never write the thing that I intend to write the first time? I actually woke up at a decent time this morning, which means I got less sleep than usual, and that's my excuse. Over h squared. So I want to break this up into two different limits. I don't know if this is really all that valid. This feels like it might not be. Actually, we can do a plus there. And how I'm interpreting this is, if you have a random function like that, and this is your x, then you would have one secant line there. No, that's x plus h. Oops. And then another secant line the same distance forward on the function. That's what seems like is happening, and I guess those two secant lines you could say are like the concavity. I don't know if this is necessarily valid. That's at least how I'm interpreting this, though. Bob, you have an exam tomorrow. Give you a tip. Don't fail. That's my tip. Taking a 3-point approximation. Amazing. Yeah. And so by pigeonhole principle, you must pass, right? That's pigeonhole principle. I don't know. I'm just taking a screenshot of this quick. I don't know if I'm gonna use this. Yeah, Zach. Basically, if it's estimating the second derivative, I'm thinking these two secant lines, you can maybe say that they approximate the concavity. That's how I'm kind of interpreting this kind of numerical like thing for the second derivative. But it's not really the answer to this person's exact question that they're asking here, but I think I'm going to throw this in. Yeah, exactly, Zach. Almost kind of Simpsons rule-esque, but for a very different purpose. Well, not like very different. What does Simpsons rule do? I don't remember that much. I just remember it uses parabolas. Oh, it estimates the integral? Let me see. Yeah, approximating an integral. I don't know if it's really like that relevant, but just remind me of that. Okay, let me I'm gonna get this image uploaded. What is this person's successful box? Question 2024-0130. Your theory professor's gonna be confused AF, yeah. It's a risk worth taking, I think. Okay, there's the file. Give me 1 minute as I upload this to Imager, however you're supposed to pronounce it. X out of that, grab link, copy link. Let's make sure the link works. Is it going to mark it as 18 plus? Okay, good. It's not being marked as 18 plus. Oh, hey, we got some cute. It's a sad. Oh, what? I don't want to know what's happening with that. Never mind. Let's refresh here. Needing to be open comes from where L'Hopital's is valid. I'm not familiar with the proof of L'Hopital's, but it may be that it doesn't need to be a closed interval. So if you're working with a closed interval, you could always just make it an open one as well. Maybe. This is getting a little out of my comfort zone. But my interpretation, the above, and a little my comfort zone, my interpretation of the numerical methods piece is that could be split up into two, and thought of as two secant lines, which could approximate the concavity of the function, which the second derivative would give an exact value for. Normally in numerical methods, though, they don't care as much about proving a second derivative exists as long as it seems reasonable. To my understanding. I drew this to try and help explain my interpretation. Let's make sure that works. Okay. Guys, person just said thanks. Oh, they actually replied back here. I'm glad I checked because I didn't get a ping for this one. Okay, so they need help with this next one. They tried Wolfram, but yeah, it is a little bit confusing. Next one, 1a minus 4b minus 20c, good, minus 27a plus 9b. That looks perfect. 2c plus 1a minus 4b minus 20c minus 27a. So we group the c's first, which is minus 18c, good. We have a plus 1a and minus 27a, good. Then we have a minus 4b plus 9b is plus 5b. And what was the original answer here? Because the original answer was definitely off. Minus 26a, 13b, minus 18c. Yeah, so let me just work through this for myself just to make sure I'm not doing something extremely stupid, but I think they got the same thing as I said earlier. Actually, I bet you I could copy paste this. And Wolfram Alpha will know what to do with it. Minus 26a plus 5b minus 18c. What? Why is that here? Okay. If there's a minus on the outside, like with the minus 9 in this problem, the minus sign also gets distributed. So you flip all these signs inside. Your new answer for that one, perfect. And no worries on the Wolfram Alpha piece. It does give a lot more information than you need and can be a lot. Okay. Let's go back to Learn Math. Hard trig question, need help. Let's see. Tangent of x equals tangent 42 degrees? Well, x equals 42 degrees. Solved. Thank you, Jed. 90 is less than or equal to x, and x is... Oh, so you have to find... Oh, okay. So you have to add 180 degrees here because at 42 degrees, tangent is some positive number over some positive number. But they're forcing you to move to a different quadrant here, so you need to find where something evaluates to the same positive number over positive number. And tangent is positive in quadrant 1, negative in quadrant 2, positive again in quadrant 3, which is where we need to go, then negative in quadrant 4. So we get to quadrant 3 by adding 180 degrees. And so I think your answer is going to be tangent of 222, which we can actually check that. Tan 42, make sure Wolfram Alpha is going to be in degrees. It is 0.90, okay, 904. So I said 222? 904, perfect. Oh, they even draw a little circle there. So this is a 42-degree angle with the negative x-axis. And that's a 42-degree angle with the positive x-axis. In the first quadrant, where tangent is positive, and asking you to find an equivalent, or I shouldn't say equivalent angle, an angle that gives the same results in one of the other 3 quadrants. The piece that's important to remember here is that tangent is positive in quadrants 1 and 3, and negative in 2 and 4. If we're starting, I should say if we're starting in quadrant 1 and need to get to quadrant 3, so we need to add 180 degrees. Tangent of 180 equals 0. If you're talking about like the periodicity of tangent, yeah. Because tangent is periodic with just pi. And you're basically shifting over by 1 period, if that's the direction that you're going. Where we're given, tangent of 42 somewhere like around here. Actually, I should say here, like it's somewhere around there. You're just shifting over to the next curve over. If I'm interpreting you right, Jed. Wait, oh yeah, oh wait, it's periodic with, it's negative pi over 2 to pi over 2. So I'm not exactly right the way that I said it, but I guess tangent 40, no, it was positive. It would be somewhere there, I guess. I'm not smart enough for that piece, but I know that what I'm saying is right, so I'm not going to try and explain it in a different way. I'm just kind of giving them the answer because I don't know how to explain it without just saying the answer, so. They get a free answer. It's their lucky day. Unit circle? Yeah, I'm thinking about it. I think about it in terms of the unit circle. I don't want to say the unit circle exactly because this isn't a unit circle value, but that's how I was approaching this problem. That's how I remember where tangent is negative and positive, because quadrant 1 you have positive divided by positive, and then quadrant 3 you have negative divided by negative, which becomes positive. In the others, it's a negative divided by a positive, or vice versa, so you get a negative. But this is what I was visualizing in my head, that we were somewhere around here, and we're going to get the same answer. I mean, in my head, I was using root 2 over 2, but 42 degrees isn't exactly that. So, but either way, you just have to get the equivalent angle around here. Okay, let's see if we can find a new question now. vertex form of a parabola. They have an answer though. This person is usually on point. So let's move on. Are there closed sets in topologies? No one knows. It's a great unanswered question in math. ODs, problem books with solutions. Should we spread the good word of Paul? Let's spread, yeah, it's not a book, but I think this person would appreciate hearing about Paul. One day I'm going to go door to door asking people if they've heard the good word of Paul. Does it actually have practice section or practice problems in these? I know for not every single section has practice problems, unfortunately. Oh man, the differential equations don't. Description was clickbait. Oh, you looked at it for yourself? Oh, does the existence of a limit? That one? Talking about a plus b equals, oh, a plus b equals c. That's probably the one you're talking about. Oh, what? Oh. Yeah, as I that that sounds like someone else figured it out and they got a satisfactory answer. I'm not gonna. I think I understand kind of what's going on, where they're asking about basically shifting a normal distribution, but there's no point in trying to figure it out for myself when there's already an answer. Calculus 2, The Struggle. That sounds like the name of the movie. Let's just see what's happening. I was asking kind of like general advice, which is hard for me to give. Let's go over to Ask Math. That's not 2 cosine x. What's happening here? Okay, they're asking to explain. So this is 2 cosine x plus 2. Because this is vertically shifted up. Two cosine x plus 2. I can tell because the middle line, because if you draw a horizontal line through the middle, it goes, how do I explain this? The baseline, I guess, because if you draw the baseline of the function, the horizontal line cutting it in half, it's at y equals 2. For g of x equals 2 cosine x, we expect our baseline to be at 0 because that is the default and we haven't done a vertical shift. What the 2 does in 2 cosine x is stretch the graph vertically by 2. Rather than going from +1 down to -1, 2 cosine x will go from +2 down to -2. I want to look at this person Desmos. I'm going to give them all of Desmos. Actually, let me even pre-program in some x plus 2. And I can share this specific graph, can't I? I can. Hey, Star, it's going good for me. How about you? If you're trying to visualize how sinusoidal functions change, I'd highly recommend you play around with Desmos. I've set up 2 cosine x and 2 cosine x plus 2 so you can compare. You should definitely mess around with modifying the values and see how the graph changes. Or I mean, I should say I definitely recommend. I don't want to give them orders. Definitely recommend mess around with modifying those and see how the graph changes. Okay. Leave. Anyone finds this explanation way too fucking confusing? Let's see. It does have an answer though. Sorry, I'm sorry that I forgot, but I think last time you were here, saying that you have a test. Maybe it was like earlier this week. I'm getting mixed up that I'm sorry, but if you did have a test, then I hope it went well. But a reasonable, well, that's kind of depending on the population. Like, you're talking about people or bacteria, or like, you need 2 points. So I don't feel confident enough to answer that person's question. Or you can try a few points and see what looks about okay if it's fine for your purposes, but... Wait, I'm getting paranoid about my YouTube audio. Test, test, test. Okay, no, never mind. I just want to make sure that it was like my mic was coming through. Let's see what else there is. Inflection points in order of derivatives. Okay, oh god, this is let k be a natural number that doesn't include 0. I think it's with the slashes at least. F. Oh no. That's not like the complex C. What is that C? Maybe it's a family of functions. I don't know what kind of function C would be though. I don't know the notation here, unfortunately. How do I project a plane or a surface over a plane? Wait, is that z equals, does z, I feel like z equals x plus y, isn't this like diagonal plane? Because if you replace z with 0 here to get the xy projection, you should get y equals negative x. Oh, it's a hexagon. That's just the way the Desmos is drawing it, though. Okay. Positive x, positive y. This doesn't seem right. But why isn't it right? They're working with like this little area down here. Can I shift this, please? Hey, no, bad. I don't know how I pan this. Do I have middle mouse? Okay, fine. No, stop. But yeah, we're working with like, I guess this area here. I guess the drawing is accurate. Oh, you take z equals 1 because that's what the upper plane is. It's basically always the same process, though. I have a hard time giving this person general advice. So this isn't something I normally like. I do it intuitively in my head, to be honest. Even though it's not probably not the most, well, I mean, for me it works, but it makes it hard for me to explain it to others. Yeah, I wish I could give them a better answer, but I have a hard time putting it into words. I just visualize it as best I can and figure out what it must be. But that's a pretty crappy answer to give to someone who's asking, like, who doesn't know what it must be. So Not a lot more that I'm seeing. Sure, math homework help, even though it's kind of dead, but let's just try it. No. No. They just want the answer. You have a 0 at x equals 2 and x equals -3. I'd probably start by working with that, but like, I don't like the way they're asking for help. I could try and give them a hint, like that, what I just said. And the asymptotes, yeah. If you have an asymptote, yeah, that gives you, okay. Well, let's work out for ourselves. I'm not going to give them the answer, but we have quite a few clues here that we can use to try and build this. So that's not an equal sign at all. It's like the opposite of an equal sign. So on top, I'm just going to start with x plus 3 and x minus 2. See how it looks. On the bottom will be the vertical asymptotes, which are -1 and +1. And we're nearly there. So we can see we need a vertical flip. So let's just slam a minus sign in front. And we're actually done. Why didn't I get the actual... I wonder why my sign was flipped. Could I have caught that before? I don't think so. Parabola shape opens downward. I mean... I don't buy that. I just feels like that rule shouldn't apply here. I don't have a good reason. I don't have a specific like reputation for that though, I guess. I don't know. To help get you started on the question, we can see the function has zeros at x equals -3 and x equals 2. And vertical asymptotes at x equals -1 and x equals 1. Those are clues about what the numerator should look like and what the denominator should look like. That's all they get. If they even asked it in a slightly nicer way, or like, and like, they did say thanks, to be fair, but if they asked like, you know, how do I start this question, I probably would have given them even more than what I just said here, but when them to decimals, yeah, sure. Fair enough, Jed. We can have that link though. It just goes to a blank one. Ooh. It's my DM. Oh, good. Yeah, see, this person was actually kind of this. I just like the way they asked the question more, so it was also hard to explain without giving them just the answer, but this person put a lot more effort into actually like typing things out, which I guess I appreciate. She you feel like more willing to just type things out too. Okay. Forgiveness portion of life. Yeah, there we go, Jed. It's a good math way of saying it. To be fair, that person's image wasn't like flipped or rotated, or there wasn't some weird like lighting or. So they at least had a nice clean picture. Which I feel like it should be an expectation, but solving an OD with partial fractions? I'm just kind of curious to see what's up with this. Yeah, that's an answer. Ugh. This isn't partial fractions. Yeah. Okay, I thought it'd be a very different question from the title, but no. It's still a good question, just not the one that I thought it'd be. Okay, and it has an answer, so let's not worry too much about it. What I think we're kind of out of questions on Reddit, and I'm really interested in looking at the real analysis stuff that we were doing this morning. So I want to switch over to the setting real analysis. Because a lot happened today and I'm still wrapping my head around it. I'm going to bring up our notes too, preemptively. Okay. So, I don't feel the urge to re-review 1. For 2, I did want to revisit a part of this here. Let me zoom in so you guys can read it. And then let me size things down so I can go to the board. Okay. Okay. Green. So, I'm going to start with part D, where all great problems start. And I'm just going to remind myself of what we actually did this morning. So, well, it was probably afternoon. I don't know. It was morning, for me at least. Actually, no, I do need to do the initial setup of the problem here. So, before I even get into this parabola stuff, let me do that in black. So the interval made by absolute value of x minus 4 is less than 1. You know, that's in the way that OB taught me. We treat our center as 4 because we're thinking about the distance between x and 4. And our distance has to be less than 1. So we're going to go 1 above, or 1 below and 1 above, 3 and 5. And our answer to this inequality is the open interval going from 3 up to 5. And then we're given a variety of different inequalities and had to find a constant, more or less, such that we still cover this entire 3 to 5 interval. And the one that we kind of spent the most time on was this parabola in part D is less than V. And you have to name a V such that this inequality covers 3 to 5, basically. Or like, you know, this interval up here. So if we draw this two-dimensionally, so this parabola has roots at +3 and +4. 3, 4, 5. And so because it's absolute value of a parabola, we bounce up here, we have a little hump. This is not how a parabola looks, by the way. It looks like a person, that looks like a person waving their arms, but I mean, this still looks like a person waving their arms, I guess. And how we worked our way through this problem is that if we want to choose a value of V such that this inequality covers at least between 3 and 5, we basically need to capture this part of the parabola here, where the parabola goes at least past that 5 mark. But getting the actual value of V can be tricky because this isn't trying to scale. This hump could be very tall. So we can see from the graph, we either want the point where this parabola is equal to 5 or the very top of that hump, but we worked out, and I'm not going to go back through it, that this point where x equals 5 is indeed greater. And so we would want to take V equal to 5 squared minus 7 times 5 plus 12 is 25 minus 35 is negative 10, 2. Okay. So if you plugged in 2 here for your V, let's actually, I think, does Desmos do the shading? I don't think it will, but it might. I think it will represent in some other way, right? Just to really drive it home here, because my brain needs it. YX? Oh. Well, that's not what you want. If I said f of x is equal to that, and then I said g of x is equal to 2, can I say f of x less than g of x? What will that... Ooh! Okay. And so you can see here that we're covering at least the area between 3 and 5 with this parabola. If we made it 1.5, we're no longer quite hitting 5. And we could make it 3, and we're doing too much, or we're doing overkill. But I think 3 is perfectly valid too. It's not just not the most interesting point. Okay. So I feel comfortable with that. In part E was basically the same idea. It was a little bit harder. We had to do some calculus to prove that none of the humps from the cubic were greater than kind of the endpoint there with 5, but it did turn out to be true. Or, we still take 5 as our endpoint, or as our value to plug in for x to get our V. Basically the maximum over the interval. What I wanted to do, though, was apply the same approach to part C. Because we did part C in kind of this number line way. But I want to see it. I want to see it in this two-dimensional graph way. I think it's going to help my own understanding if I can draw it both ways here. See it? Yep. You feel me, Zach. So we have 3, we have 5. That's kind of spaced out, isn't it? This is not drawn to, this isn't even close drawn to scale. 3 and 5. So let's start with x minus 3. So x minus 3 is going to be the absolute value function shifted to the right by 3. We call that case of 1 instead of just k, because to emphasize that these are separate k's that we're working with in each part of part C. And so, honestly, the graph kind of answers this question for us right here, because if we want to cover the entire thing between 3 to 5, it's pretty clear to me that we want to take that point where x equals 5, because between 3 and 5, it's increasing linearly with nothing especially crazy happening here. And so that means we want to plug in 5 minus 3 is equal to k sub 1, and get k sub 1 equals 2. And I think that's what we said it was in class. I can actually look back at our work. I know the screen capture is a little bit like messed up, but this will only take me seconds, so I don't want to bother changing it. Yep, k sub 1 is greater than or equal to 2. And so you could, of course, take any line that's also higher than this, and it's completely valid to cover this 3 to 5 interval. Okay. I guess we should try it. Yeah, I think doing the second part is going to help me out too. So let's do the second part. It's going to be basically the same argument, but it does look a little bit different here. Okay, so here, this is the absolute value function shifted to the left by 2. I should have drawn 3. And so here again, we can do the same exact thing where it's increasing linearly to the right of -2. And so naturally we want to take x equals 5 as our answer. K sub 2 is equal to 5 plus 2 is equal to 7. Okay. And we did indeed say that k sub 2 is greater than or equal to 7. Perfect. Okay. So good to know this two-dimensional graph approach does work the exact, or you know, gives you the exact same result as the one-dimensional number line that we were using for part C. Actually, wow, that screen capture is like perfectly aligned. So I don't know if I want to go back through part number 3 specifically. Maybe I want to look back at our work, and then I'm going to apply the same work that we did down here to these part 4 proofs, because we did skip these, because I was saying that I could probably do these on my own by reusing our work from part 3 here. So let's look at our work for part 3. So part 3 was up here. Okay, so let me reread the prompt too, just to make sure I'm on board. At this point, this course is engaged with what happens when a sequence converges or diverges. The goal has been to choose an end past which all term indices, small n greater than big N, are within epsilon of a proposed limit. However, when considering functions that have inputs and outputs, and specifically those that are real valued, there are two sequences to consider. Let's think about the function f of x equals 2x. Make three sequences of inputs as close as you wish to an input of x equals 5. How do you show that all three sequences could converge to 5 notationally? So over here is where we did our three sequences. We did the top one and the bottom one. We're approaching 5 strictly from below or strictly from above. And then I just oscillated up and down, going by a half of the last interval each time, just to be different. How do you show that all three sequences converge to 5 notationally? And I think the answer for that was this first thing here, that the absolute value of x minus 5 is less than alpha for any alpha greater than 0. And I think that's all the justification that it sounded like was needed. My thought during class was that we'd have to, get a sequence in terms of n for each of these x, or, for each string of x values here, and actually do a proof. But I'm kind of glad we didn't have to go through and do like 3 different proofs. But I think just saying the absolute value of x minus 5 less than alpha is good enough. Assuming your above sequence converges to 5, your new sequence one that converges to 10, and that is double your sequence from part A. How could you notate this? Well, I think we were going, maybe like this was jumping the gun almost, but you could say that the point is that any sequence you make will converge to 5. What do you mean by any sequence? All the top rows of your tables. Okay. So when we say any sequence, I'm thinking like n's, or like x squared, or just like, doing, x equals 1, 2, 3, 4, 5, 6 out to infinity isn't gonna. Any sequence of inputs f converges to 5, the corresponding output sequence will converge to 10. Okay. Because we did this, absolute value 2x minus 10 is less than beta thing, but my thought from the wording of the question here is that we would take this inequality, multiply it through by 2. Not necessarily connecting it to 2x minus 10 yet. Although I think Obi knew where the proof was going. How do these sequences connect together? Oh, well, I guess after reading part C, originally I could use sets, so this is for meeting 10. Oh, good. Okay. Man, in the same week, we're going to do epsilon delta and like sets. Those are two of my least favorite things. These are a few of my least favorite things. Okay, but the hills are alive with the sound of epsilon. Should be in a musical. Yeah. So I gotta ask, I don't know if section 2 is gonna interpret it the same way as I'm doing it, but if Obi hadn't written this, I would have interpreted it as we're supposed to just like kind of short circuit this part and just do 2 times x minus 5 is less than alpha, or like, multiply each side of that by 2. And kind of skip over that whole beta step and relating back to alpha. But then when I read C, it seems like we're supposed to name a different constant beta. Hey Tom, over on YouTube, you can post the question in my Discord, or you can type it out there in chat too if you can. But sometimes using Discord is easier if you have like a screenshot or something. Yeah, I'm happy to take a look. Put in the Discord. Sounds good. As soon as you post it, I'll switch over and take a look at it. Okay, so regardless of how we get there, we do get to, we have the relationship absolute value of x minus 5 is less than alpha. And we can multiply each side by 2 to get to the absolute value of 2x minus 10 is less than 2 alpha. And 2x happens to be our function. And so we just shown that the function is going to converge to 10. Okay. Since we engineered the sequence of inputs so that they converge to 5, when we get to our function, okay. I just have to make a little connection there. That's help me realize how this is a proof that the function converges to 10. Knowing that we've engineered our sequence of x's to converge to 5 already, we can, okay, that, I'm glad I looked back at this work. Because this did not feel like a proof to me when I first saw it. But you're really just modifying the sequence in the same way that the function happens to modify inputs. And Tom, if you want, you can post it in the math homework help forum there. Sure thing. Oh, no worries at all, Tom. Take all the time you need. Let me erase the board, because either way, I'm done with question 2 off that sheet. Okay. So that was just 3 we were looking at. Some 4. I don't know if okay. Maybe let's like start to think about this whole linear business for number 4. I won't get too in the weeds yet. I'm just gonna have to about that to use the whiteboard for a different problem here, but we're going to prove the limit x approaches 2 as 7x plus 9 is equal to 23. We just plug in 2 for x, duh. Why do you need to do this stupid proof? m not equal to 0. Really, this one has m not equal to 0, but this one doesn't. Okay, I should probably, not get too ahead of myself before I even done part A. You know what? I'll just start working the board. And if I need to make a little section to keep that work there, then it's fine. And Tom, whenever you do post it on my Discord, just let me know in the YouTube chat, just in case I don't see it immediately. But again, like, no rush. I'll be streaming for a good while. Prove the limit as x approaches 2. You want me? All right, thank you. 7x plus 9 is equal to 23. All right, so we want to take the absolute value of x minus 2. It's less than delta. Don't accidentally write sigma again. I don't know why I always get delta and sigma mixed up. And we want to get to the point of 7x plus 9 minus 23 is less than epsilon. Well, we might need to do scratch work, but I need to remember, like, oh yeah, okay. So I think we start with this more complicated one to do some scratch work with it. So we can figure out our choice of delta for a given epsilon. You might come back later. Actually, you need to take your dog to the vet. Oh, shoot. Okay. Yeah, Tom, please take your dog to the vet. And if I don't happen to be online, still post it in the Discord, and I'll get back to you offline. So I was trying to think. It almost looks easier to just do it in the forward direction to me off the bat. So we're given epsilon, we have to choose a delta. But I feel like I'm thinking about this wrong. If that's the case. Okay, I need to look. Let's just. Okay, wait. Maybe I'm making this too hard. Let's just start from the delta. Multiply each side through by 7. So this is equal to 7x minus 14 is less than 7. That's not a 7. minus 14 is equal to plus 9 minus 23. Are we just... So would we take 7 times epsilon or 1/7 times epsilon? Seven times epsilon. Or I guess we just have the relationship 7 delta equals epsilon. And so if we're given an epsilon, we would choose our delta that is epsilon over 7. Oh, hey, Conic? I guess I don't know how you pronounce that name, but welcome in. How's it going? Let me look back at the work we were doing. I guess what I just found is we don't need to worry about the vertical shift. I want to find a way to like convince myself more of that though, if that is the case. We could try naming values of epsilon and testing our delta. So our function, well, we have 7x plus 9 minus 23. I'm just going to actually type that out, even though it's not really needed. Let's just say, just take 0.01 for epsilon. See what Wolfram tells us that this should be. Okay, 1401 over 700. So we should be able to take how am I interpreting this? If we do a second tab now and take x minus 2 is less than 0.01 over 7, as I was saying, we get the same number back. So maybe my proof is valid, except I should maybe check a bigger value of epsilon, because we have to do like a minimum of... So if we have epsilon equal 10, I should do 100. So something that's very obviously out of range here. 114 over 7. Oh, maybe that's okay. Wait, that gives 128 over 7. Why is that? (1014) over 7? Oh wait, it was already over 7. Was that my issue? Yeah, I need to divide it by 7 again. 114 over 49. 212 over 49. That's not right either. But is it still valid? Hmm. I need to look up an epsilon delta proof, I think. I thought this would be a bit simpler. I have a hard time interpreting the values that I'm getting. Um, Given any epsilon greater than 0, there exists a delta greater than 0 such that for all x not equal to c, if x minus c is less than delta, then f of x minus L is less than epsilon. And so yeah, we were replacing the delta with epsilon over 2. We're using alphas and betas just to not, just like, be different, I guess. So I feel like if I'm just copying what we did in our work here, I think my proof works. I'm not sure exactly. If we take go back to our 0.01 case. That's not 0.01 over 7. Well, here we got the same thing. I don't know if I should be expecting the same thing back. I guess that's where I was getting partly tripped up. But if I take this, I plug in 1401 over 700. We get 0.01. And we take this, plug in 1401 over 700. It's 2. We get 1 over 700, which is 1/7 of this. Okay. I think this proof is okay. Not confident, but I think I'm going to call it okay and maybe try part B now. That's not how you scale, is it? It's pressing the Windows key instead of Alt. Or crop, not scale. That is how you scale, it's not how you crop. Oh no, what did I just do? Oh, I moved my alerts over? Yeah, dude, that's what I wanted. How do you know, OBS? I really wanted to move my alert window randomly over to the left. Okay. So for part B, prove the limit as x approaches 2 of mx plus b approaches 2m plus b. With m not equal to 0. So this is basically proving what you would do in a calculus class with just plugging 2 in for x for your line. In the specific case where x approaches 2, I guess. And then the next one will be proving it in general. So our same setup, x minus 2 is less than delta. Mx plus b minus 2m plus b is less than epsilon. So if I do the same thing that I did last time, I shouldn't. And I multiply both sides of this, not times 2, but times m. So that's why m can't equal 0. Because then this whole thing becomes 0 less than 0. M is a negative number, though, potentially. We have to allow for a negative m. Would a negative m doesn't change anything, though. Well, yeah, it does. It kind of does. If we're multiplying by negative m, we flip the inequality, don't we? How do you deal with that? Multiply by, oh, that's a good point, Zone Ranger. Yeah. Okay, I like that. multiply both sides by the absolute value of m, as Zone Ranger says. Thank you for that. Now we can do what we want here. And now we do some plus b minus b business. That doesn't change the value. So we've now gotten the relationship absolute value of m times delta is equal to epsilon, based off this and relating it to that. So we are going to say our delta, I guess this is another reason why m can't equal 0, because we're going to divide by m. Okay, so that's our choice of delta for a given epsilon. That seems okay to me. I don't know how we're going to get around this issue for part C, though, where we can allow m equals 0. Could we take... I think we made to take two separate cases here, though. Okay, yeah. I think we just do basically the same proof we did here, but with C, for m not equal 0, and then for m equals 0, we can prove that we're going to end up with b equals b. That's my guess. So actually, maybe I can just modify this work even. X minus c is less than delta. Mx plus b minus mc plus b. C. I'm not speaking Spanish, but MC, MC. This now matches that. So the rest is going to stay the same, but now for m equals 0, our problem is going to become I guess we would say x minus c is less than delta. 0x plus b minus 0c plus b is less than epsilon. Well, it should approach b, is what we're expecting. Oh wait, no. This is just 0 is less than epsilon. That is true, because epsilon is greater than 0. But this doesn't feel very meaningful, does it? I could back up to this statement up here and say the limit of x approaches c of b, because there is no x, it should just be b, I guess. That doesn't feel right, though. But maybe I'm making it too complicated. No, I feel like it'd be wrong to just do my calculus thing and say, oh, we obviously like, have no x here when you plug in m equals 0. So it has to just be b. Like, I feel like I feel like we have to do something here. Some kind of... Like, what is x and c then? Hmm. So actually, this does show that this function approaches b. That's still a definition of a limit, and it is always true. We don't necessarily even have to go to delta. Maybe that's enough. There's a check mark there that someone smart drew, so... Maybe that's all that you need to say there. I'm not completely sure. All right, at least for now, I'm just going to take that problem 4 as done, I guess. Might realize that later on I made a horrible mistake here, but let's review. We did problem 5 in class, but it was kind of hurried, and I kept getting stuck. So I want to review the work that we did here. Over here. Okay. So, part 5, this is stuff that I was writing, kind of struggling through. We set up the absolute value of x minus 6 is less than delta, because x is approaching 6. And then we set up the function 1 over x minus 4 minus the proposed limit a half is less than epsilon. And so I got a common denominator. And then the over 2 can come outside and get multiplied by epsilon. And then we split up the absolute value based on the fraction. And if we know that we're a certain distance away from 6, we must be at least 3 times that distance away from 4, trying to interpret this ratio of absolute values here. Because if you take the worst case scenario, you have the distance. Okay, so we just use a distance of 1 as an example. You're allowed to choose whatever other distance you want as long as you, I guess, compensate for it. But if we just take distance 1 from 6, basically x equals 1 here. You can be, between 5 and 7. And if you try to cover that 5 and 7 interval with the distance from 4, you need to go out at least 3. Yeah. If this distance is 1, this distance has to be 3, which is where this 1/3 ratio comes from. And so you would take 2 epsilon is equal to 1/3 and divide by 2, and you get epsilon, well, not equal to 1/3, but you want to scale it. This part gets very tricky, but because you have 2 epsilon, you need to divide this 1/3 by 2. It's just kind of hard to relate these two directly, I guess. Because this 1/3 ratio is for this function, but we actually had a multiple of a half there for the actual function that we were interested in. If I was doing this on my own, I wouldn't know whether you multiply or divide by 2, though. It's kind of what I'm trying to work out why. Like, I guess my guess would be that we divide by 2. I just have a hard time explaining it. The other thing that I need to figure out is why we have the minimum of 1 or epsilon over 6. I know it's to compensate for a large epsilon, but like, why isn't epsilon over 6 valid? Do we end up with negative numbers or something? Well, if it was min, it would choose... I don't know how min works with negatives. Hey, Debella, can you say something on mathematical induction? Something on mathematical induction. There you go. No, yeah, so like, I guess maybe, can I ask you what context you're maybe working on induction in? Because it's something you can do kind of formulaically, but it's hard to understand why it actually works. I kind of look up maybe if there's like a relatively simple proof for inequalities. Okay. Inequalities are a little bit trickier to do inductions with because they have because there's like a few tricks that can happen. But I guess let me explain about mathematical induction in general, both for inequalities and the things that I'll say apply to both inequalities and equalities. So the process that you can always follow without understanding it, or even if you don't understand it, you can always follow the process of induction, which is you prove your base case, which is usually n equals 1 or n equals 0, but you'll almost always be told like where you're starting in some way. You then assume that it's correct for some, arbitrary index k, and then The induction step is you prove it for k plus 1 after having assumed k. So you basically start... I always start with a step for k and work my way towards k plus 1. Oh, you can do it this way too, though. Actually, yeah, okay, no, this is basically the way that I did. I just phrase it differently. So, shoot, it'd be so better if I have an actual example here. It's kind of dangerous to do this blind without knowing what or like how the answer is going to look. We could try this one together, though. This exercise is to prove that 2 to the power of n plus 1 is greater than n squared for all positive integers. So let's try this one together. And hope I can actually get a correct proof here. Induction does have, especially with the inequalities, there's some tricky steps. But what I recommend, if you're just learning induction for the first time, the way that I learned it is I just memorize the steps that you're supposed to do. Then I learned the patterns and how you actually do the induction step. And then after I did, 1,000 induction problems or whatever, I understood how the proof actually worked. So if you're just trying to get through a class, I'd also recommend that you just start by, memorizing your steps and just trying to notice the patterns and letting that sink in, but without worrying too much about how the proof actually works or why it works. So what we'll try to prove is 2 to the n plus 1 is greater than n squared for all positive integers. So they say for all positive integers, and that means we're starting from 1 and doing let me actually, so all positive integers means 1, 2, 3, 4, 5, dot, dot, dot. All the way up to infinity as far as you want to go, but we start from 1. So let's prove our base case. So to prove our base case with n equals 1, we really just plug 1 in for n in this inequality wherever we see it. So 2 to the power of 1 plus 1 is greater than 1 squared. 1 plus 1 is 2. 2 squared is greater than 1 squared is just 1, and 2 squared is 4. There we go. 4 is indeed greater than 1, so we've proven our base case. Now we assume, and the step is represented differently depending how it's taught. So if you weren't taught the exact same way, or the exact same representation, you're probably taught something that is the same, but it just looks different. So if it does look different, then please let me know. This next part probably isn't necessary for your purposes, but for some k, or for some positive integer k, or it kind of depends how that's structured based off your teacher and how strict they are, but all right. Now comes the harder, or I guess I hope it's the hard part, which is the induction step. We want to prove the next term. I'm thinking about how I should phrase it. Let's just say we want to prove it for 2k plus 2 now greater than k plus 1. Very important, it's in parentheses, squared. So I'm trying to write a bit neater. So I took this inequality, and whenever I saw k, I put k plus 1. So this k plus 1 become k plus 1, so k plus 2. And this k becomes k plus 1 in parentheses squared. And that parentheses changes everything. So it's important to, you know, too many parentheses better than too few. So the thing is, if we want to prove this, we can't start from this step. It's a logical error. For n equals k. Yeah, Jed. I think Jed is applying maybe a bit better language. I'm not being too picky about the actual like language part here, but yeah, what Jed is saying is perfectly fine too. I'm just gonna stick with this though, for the sake of this proof. So yeah, as I was saying, this thing we want to prove, we're not allowed to actually start from the step. We have to start from the thing that we're assuming, and we have to build towards this, like whatever it takes. So starting from this step, I think we're gonna have to use an inequality trick here. So just looking at the left-hand side, we have 2 to the k plus 1. We want to do anything it takes to make this 2 to the k plus 2, because that's what the thing we want to prove has. So I'm going to multiply each side of this inequality here by 2. So we get, if you remember your exponent rules, when you have the same base, the exponents add, and this is like 2 to the 1. So it's 1 plus k plus 1 is the same thing as 2 to the k plus 2. It's greater than 2k squared. Now we have the tricky part of the right-hand side. We have 2k squared, and we have to get to k plus 1 squared. And I'm still trying to work out exactly how we're going to do that. Because, like, especially with inequalities, this is it's not easy to do this. I think... Oh, wait. That inequality doesn't go the right direction, does it? How would we do this? We need to name... Is k plus 1 squared greater than 2k squared? I can't imagine it is. Where is it? Sorry, I'm still kind of puzzling this out, but k plus 1 squared, this is just kind of some scratch work that I'm doing as an exploration. Multiply this out, it's k squared plus 2k plus 1. And try to figure out how this compares to that. So what I'd love to do is kind of make a another branch to the inequality here and say that this is greater than k plus 1 squared, and you could take that step and you have your proof. I don't know if this is valid yet. That's where I'm trying to go with this though. It has to. We prove the base case. What do you mean by that, Jed? You know what? Okay, just before I go off completely the wrong tangent, let me graph this. In developers, so probably want to see, like, let me know because it's just a random one that I saw, hoping it wouldn't be too hard. I'm getting a little tripped up on this step, though. I'm sure I can find a proof of it, though. Possibly, if you... Oh, sorry. Oh, it's not even true, dude. So I just went down the wrong path, so... Okay, well, let's go this before I like completely mislead you even more. Prove. I mean, not mislead you, but this is an exploration trying to prove these, and it's very easy to go down the wrong path, like I just did. Wait, did I even read the 2 to the n plus 1 greater than n squared? Oh, they do just 2 to the n. I was right? Um, oh, you know what, Jed? With our conversation before with induction, okay, looking at this, I think you can start from your n plus 1 or k plus 1, but you can only work with one side at a time. I don't remember what you were doing. Okay, so that makes a bit more sense about whether you start from the n plus 1 or n. Sorry, Bell. It looks like, so yeah, I think I am right. I just need to figure out if I'm the reason that it's right. So, okay, we need to verify this claim, because that's the same exact claim that I was trying to make here too. And what do they say? That n minus 1 squared is greater than or equal to 4 squared is greater than 2, since n greater than or equal to 5. Oh, thanks, Dabella. Yeah, I'm here to help, and if I hate just I hate being like a hindrance though. Like I feel like I'm being right now. So, um, I guess I should have chosen one that's a bit more direct because I don't. I I, I don't blame you for asking me to talk about inductions with inequalities because they're tricky for this exact reason. You have to prove things like this. For n minus 1 squared is greater than 4 squared is greater than 2. Oh, wait, maybe building towards it like this. N squared plus n squared. And n squared. Oh, I kind of like this one. Down here. Where you just build towards it incrementally. Okay. I think I think I like this proof much more. I think they're the same proof, but I like the phrasing of that second one more. It's more intuitive to me at least. Okay, so we can bridge the, so like this claim, I'm saying it like I needed this to be true, but I was having a hard time actually showing that it's true. And let's examine what 2k squared is. 2k squared is the same thing as k squared plus k squared. But we're trying to build it towards to match k plus 1 squared in some way. So in the spirit of doing that, we're going to transform this k squared into 2k plus 1. So I'm just going to write out the next step, and then I'll match what's going where. So this k squared stays the same. That I don't know why I did the bracket and the arrow. And then this k squared we're saying is greater than 2k plus 1. Which we're going to say that's just like, you know, self-evidently true. You could prove this relationship inductively too, but this one is, it's much more clear to see, or it's much easier to accept that k squared is greater than 2k plus 1, at least after a certain point, which we don't have to worry about here. And so that's why we can say k squared plus k squared is greater than k squared plus 2k plus 1, because we're using this little relationship here and transforming that k squared into that, and we switch it to greater than rather than equality. And conveniently, this factors to k plus 1 squared. And so if we take this step and jump forward to this step, we take the inequality in the middle, we know that 2k squared is greater than k plus 1 squared. And that means we can make, now we can validly make this kind of chain of inequalities and take these two steps and say that 2 to the k plus 2 is greater than k plus 1 squared. Okay. And that's what we wanted to prove. And something that I was something like, so I was making the point that you should always start from your assumption and not starting from the thing you want to prove, but you actually can sometimes, you can kind of start from the thing you want to prove if you're careful about it. And it often does get taught this way, where you can start from one side of your proof. So I started from the assumption, which is fine too. But it actually, I think it more commonly gets taught, at least in my experience, to start with one part of this inequality. So like the proof we looked at in stack exchange, they started with that side, and they just said 2 to the k plus 2, and they did whatever they had to do to use the assumption. And so they pulled a 2 out of the exponent, doing the reverse of what we did here. And now we see a k plus 1, so we can use our assumption and say it's greater than that 2 times k squared. So you technically can work with the thing you're trying to prove, but only one side of it. And at some point, you always need to use your assumption. So, DeBell, I'm sorry that I was waffling around with the explanation. I hope that kind of makes sense the way that I explained it, at least at the end. If you have a specific problem you want to see, please let me know. And I was avoiding talking about it, but the reason that induction works is you prove it for your base case, your very first number. And the reason you're allowed to make this assumption is because we've proven the base case. So we've proven it for, k equals 1 here and n equals 1, however you want to call it. And so since it always works for the next number after that like The entire idea is that you prove it's true for the first number and you prove it's true for the next number right after that. So we've proven it for 0, and for 1, and then we prove it's true for the next number after 1 too. And so once it's true for 2, it also works for the next number after 2, which is 3, and the next number after 3, which is 4. And it kind of like cascades down the list like that, where you prove it for your very first one, and then you show that no matter what, it'll always work for the very next one. That's the idea behind why induction proof works, although that you don't need to know that to actually do a proof by induction, as long as you know what your steps are. So if there's something more that you want to see, Debella, please let me know. I hope I won't struggle with it quite as much as I was, but induction proofs, I think they're kind of fun, honestly, but there's a couple of tricks that can really catch me, like that one had. Because inequalities are kind of a different beast. Because you have to do kind of crazy things like splitting up 2k squared and k squared plus k and remembering what it's greater than. Okay. I do feel like this person is channeling Zach with using spades to call an equation. Shed came in, you completely missed the proof. Aw, dang. Well, shoot. Did you hear the part where I said that you're like, or the way that you were taught? I think I understand it better now that I saw the proof on Stack Exchange. I'll just like re-explain like that part of it. You are allowed to start with the k plus 1 step, but only one side of the equation. So like the proof on Stack Exchange is starting with just the 2k plus 2. You say it's equal to 2 times 2 to the k plus 1, and then you can use your assumption, and that is logically valid. Because you can't use the entire thing that you want to prove, but you can definitely use one part of it. And so maybe the thing you did was actually right. But I think it's actually the way that I was taught too, but I just forgot because ever since I started streaming, I get yelled at if I start with the thing that I want to prove. So I assumed that it was wrong. And I realized that because of this second response on the Stack Exchange thread, if you want to see even more. I'll put it in the YouTube chat too. All right, so I don't see anything else from you, Debella. Please let me know if anything else does come up. If not, I'm just gonna go back to doing some real analysis stuff that I've been like studying for fun, basically. Thank you for asking a question, though. So I believe, yeah, I was working on 5, and I was trying to remember, or I was trying to kind of like work through the logic of 5. Okay, so we were examining the ratio of these two absolute values. We arbitrarily chose 1 just for a distance between x and 6, and found the distance, if we want to cover from 5 to 7, with a distance from 4, we need to have it be at least 3. A flaw in what I did, Judd? The base case is too low? Yeah, that's why I graphed them on Desmos, because the two parabolas cross over at some point. So I think the question is actually not well formed. Because they said for all positive integers, and I guess if it's not true for n equals 3, you get 2 to the 4 is 16 is greater than... It holds for n equals 3, right? You get 16 is greater than 9. It does hold for 1. We showed that. It's hold for 2. 8 is greater than 4. Yeah. Holds for 3. For 4. 32 is greater than 16. It seems fine. Oh, the plus 1. Okay. So the question is fine then, I guess. I did gloss a little bit over why k squared is greater than 2k plus 1, because there is a point where it's not true for k equals 2. Once you're at k equals 3, I think you're fine. So technically we could have set our base case, or we should have proven it for 2 manually, but I glaze over that a little bit just for convenience. Just out of curiosity, I want to see fraction x minus, oh, no, x minus 6 over x minus 4. Ooh, what are you doing? Oh, I guess it's like the rational function x minus 6 over x minus 4. Just this little part flips up. Okay. Between 5 and 6 shouldn't be, or between 5 and 7 shouldn't be less than a third. Why is it greater than a third here? Hmm. I don't feel comfortable with this and how it translates into 1/6 epsilon. I think I understand the logic, but I need to kind of let it, I guess, sit for a while. But maybe I can figure out why we need this whole minimum of 1 comma epsilon over 6 business. So we have it here if we have, this only matters if epsilon is greater than 6. So if we were to take epsilon equals like 10, why would epsilon over 6 not work? Or I guess we could say like epsilon equals 12 just to give us even numbers. if epsilon equals 12, we would have an x minus 6. It's less than 2. What aren't I understanding here? It's because this is going out, our interval is flipping. We want to be inside rather than outside. Hmm. This kind of style is more my instinct for what to do when working out epsilon. Hmm. Case where epsilon is greater than or equal to 4, just take delta. I should explain that, like this bit here, a bit more. Why is delta equal 1 fine? I know because your epsilon is getting very big and you don't need to be as close to x, but why 1 exactly? Hmm. So here there's a pretty clear reason to me why epsilon greater than or equal to 4 doesn't work, because you get an epsilon that's equal to or less than or equal to 0, and epsilon has to be greater than 0. But epsilon over 6 is always greater than 0, so I really don't understand that, I guess. Maybe I should look at what OB did for number 6, or maybe I could try to work it out for myself and then look at what OB did. I guess I'll try to work out for myself and see where I get stuck. I'm certain I will get stuck somewhere. So, number 6 is to prove the limit as x approaches a of x squared is equal to a squared. Right? Right. Okay. All right, let's set up our delta. Our epsilon. Then I guess we're going to do some scratch work. So I don't know, to me, the way that website I was looking at does it just makes more sense. Ah! Thank you. I literally thought before the stream started that I should charge my phone, and then I forgot to. Hey, Mac, on YouTube. Yeah, it sure did, Jed. Mac, I have a bachelor's in applied math. And we just saw me working on until my camera died is some real analysis stuff that I never actually learned when I was doing my degree that I've been going back and trying to study through a real analysis class that's being taught on Twitch. But welcome in. I guess we're working in paint. Oh, not that. Wrong paint. 1 minute. Ugh. Shouldn't have to work in paint for too long before the what's it called comes back. My phone. I'm not going to bother getting the problem on the screen because I can just rewrite it pretty quick. Okay, so set up our delta. Squared minus a squared is less than epsilon. And I want to try doing it the way that the book or the website was doing it. Add a squared to all three sides. There's three sides to every story. I just wrote a 3. That's how many. Ugh. Then we square root everything. Do it. Oh, dude, there's pluses and minuses here. Is there a reason we can just take the pluses? That'd be nice, right? How do we deal with that? Maybe I don't have to worry too much about it. We shouldn't have a negative sign out front because epsilon should be greater than 0 in delta. So now we want to, this is basically our scratch work here for our choice of delta. I'm not mistaken. And the first one is always going to be less than the second one. So epsilon is greater than 0, and a squared is always positive. And then technically we have to make sure we're not choosing a negative in the square root. I'm just gonna use 1. I still don't know why. Like, do I have, is 1 just always a safe bet or what? Actually, it's not really minimum. It's like, I'm not going to worry about that. So let's just focus on this bit of the proof and worry about large values of epsilon later. Speaking of this bit of the proof, I mean, I guess that's kind of what we wanted. For any epsilon, you can name here, I would take a delta of minus epsilon plus a squared. I think is what's happening. Feeling better, phone? Give me 1 minute. I actually need to let my phone charge for a bit more. That's the way that the website would do the proof, I guess. But like, I feel we haven't actually proven much, but I also feel like we didn't prove much with the other way. So if I were to do it the way that we're doing it in class, like, working with x minus a less than delta and doing whatever we had to do, oh, and we were working with epsilon. I'm looking back at the okay, so I guess we worked with this step and did whatever we had to do to get over to delta. So I guess we have the difference of two squares here. That's what jumps out to me. And then we could split this thing up into two separate absolute values. And then we need to bound this in some way. And I guess if we were to use the same logic as the other thing, if we take a distance of 1 with the thing that we want, this thing over here has to be 2a? Well, they're being multiplied, so 2a squared. Well, no. Two a, this distance we said is 1, so it's 2a times 1, which is just 2a, I think. So we actually have to go 2a plus 1 distance out to cover the very end of the interval over here. This is very different from... I feel like we should have something squared here, right? Or square rooted. This way over on the left feels very formulaic to me, like something that I can replicate. This way over here is very, I guess, alien to me. Let me bring up my webcam again. or my phone cam. One minute. Oh God, what's happening to you? Okay. Why is this all sorts of messed up now? I guess it's actually okay. God, dude, this is impossible. This is literally impossible. This is a struggle that I have literally every time I do a mass stream. I just do it off camera. Okay, that's gonna have to be good enough. I'm gonna get a tripod soon. Like, the thing that I have is not working. Um... So let's look at what's happening back here. So actually, I did just realize that what Obi did was for... Where was it? This parabola here, I think. As it approaches 2, I guess? Or... As it approaches 5, okay. We divide each side by x minus 2. Okay, this is where the biggest part of the proof starts, I think. Where you take delta equal to epsilon over x minus 2, where x is about 5. And so I assume here you would need to do some kind of caveat where x is not about 5. Or something like that. Or like... I don't know. Let me see how this other side does it. Okay, so we're just taking delta less 1 arbitrarily. What are they doing? So we set delta less than or equal to epsilon over 5. Huh. Multiply each side by x plus 2. One over 5 is indeed, or epsilon over 5 is indeed less than epsilon over epsilon by x plus 2. Wow. What the hell? So the forward direction of the proof is you start from the delta statement, you take your proposed value for delta in terms of epsilon and plug it in, and then you get to your epsilon statement. That's helpful for me to try to remember. Knowing this, I kind of want to this is basically the same question as I was working on, just they used 2 instead of A, but I kind of want, I think this is pretty in line with what we were doing in class, and I kind of write the proof in this term, in these terms actually. The webcam, or in the phone cam is back, so let's go back to using the whiteboard. Okay, so I guess we notice x plus a, for that is equal to x plus a times x minus a. We're interested in x minus a because that's what we have for delta, so let's say that x minus a is less than epsilon over x plus a. Okay? And so now if we arbitrarily take delta equals 1, then I'll forget what we do next. Or delta. Oh my God. How did the proof do it? Arbitrarily assume that delta is less than 1, which would imply that x minus a is also less than 1. Now what? Okay, so this means that minus 1 plus, oh my God. Why can't I write the thing that I try to write? Minus 1 plus a is less than x is less than positive 1 plus a. So if we look at that fraction, We want to bound x plus a, I guess. So do we, I guess we plus a again. One plus 2a. And then you want to invert it. Okay. Do we care about what this is greater than, it looks like? I feel like we should care about what's less than. Oh, in theory, we could have the absolute values here. I don't know. I'm really not understanding this so far. I'm going to use the bathroom though, and I'll be back in a minute. Sorry about this. All right. Hey, Sergeant Duck. How's it going? I'm gonna put this epsilon delta stuff down for now. I'm just not understanding it. See if I got anything new over on Reddit. Oh, cool. Okay, this person liked my explanation, it sounds like. Space curves. Does it already have an answer before I... Okay, no, it doesn't. Find the shortest distance between the two flies and the time at which this occurs. Ooh. Need to let time be negative. Huh. I think for part A, you would take just your good old-fashioned square root of x minus x, or x1 minus x2 squared, plus y1 minus y2 squared, plus z1 minus z2 squared, and then optimize that. The trajectory distance, I don't know what that part means, to be honest. That is a pretty, yeah, okay, that's a good point. Hmm. Hmm. I'm not sure what to tell this person, to be honest. Let's look at Paul's notes, but this one's beyond my offhand knowledge. Yeah, I don't think Paul goes over this. All right, let's move on. No comments. Angle measures of a right triangle given the sides without using a calculator. Angle A is an acute angle and sine of A is equal to root 3 over 2. By using a calculator or tables, complete. Angle A. Ah, they need to know their unit circle. Angle A is going to be pi over 3. Hold it. Oh, but they ain't in degrees though. It's what? 60 degrees? Yeah. I don't want to give Paul's explanation for the unit circle though. That's actually not my favorite. I don't have a favorite one, but Paul's explanation is a little brief. I want to find one specifically that includes a degrees. I could provide this one, I guess. Circle. Must be 60 degrees in this case. Some example values. You would take the angle where sine is equal to square root 3 over 2. Not a ton new on this subreddit. Two geometry questions. Oh no. This isn't schoolwork, so I don't have any unit topics to branch off of. Oh gosh. Oh no. Triangle ABC, M is the midpoint of AB, N is the midpoint of AC, and G is the intersection of BN and CM. The area of triangle GMN, small one in the middle is 6. Find the area of triangle ABC. I guess these lines are medians. See if there's anything that jumps out. Right? Yeah, midpoint, so medians. The median of a triangle further divides a triangle into two triangles having the same area. That might be the fact that we need. The three medians divide the triangle into six smaller triangles of equal area. So area ABN is equal to area BNC, and area MCB is equal to area ACM. Don't necessarily know how that helps us yet. It seems like there should be something to that. Yep, Jed. I'm looking at the problem number 1 that goes with this drawing up here. We have a triangle ABC. We have two of the midpoints drawn for us, or medians. We're given the area of the small rectangle in the middle is, or triangle in the middle is 6. So I'm looking at properties or in like theorems related to the median of a triangle and seeing if anything jumps out. If you want, maybe take a screenshot or something, because I'm about to change the screen. If you are gonna work on it at least. Oh my gosh. Hey, Yeller. You have a capture? All right. So we do have this property, which the median divides the triangle into two triangles of the same area. It seems like it might be relevant, but I can't use only that in a way that I can think of. Centroid, yeah. So let me needs meet in the centroid, but we don't have that third one drawn for us, and I hesitate to draw another one. Unless there's some property here that really helps us out. What does this mean? Oh, the centroid is halfway through each of the medians. Okay. Does that help us? I don't know what I can tell. 2GM equal, yeah. Oh, like that, yeah. Not in half, but 2 to 1. So I don't see how that helps us yet. Oh. Well, I guess these are the properties this site gives of the centroid. I want to look more at the medians. Hmm. Can we set up some scenario? So we have the area of GMN. We need the area of ABC. I'm gonna try one thing and hope and see how it looks. And if that one thing doesn't work out, I'm probably gonna move on because this is kind of a hard problem. Actually, it's ironically very similar to the problem that I was watching Obi work on. I think last night or 2 nights ago. I don't remember now. Obi's was much harder, but this is a very similar vibe. You found the answer? It's just finding out what to search for. Let me try my one thing here, Jed, because it shouldn't take me too long to write out. Actually, how am I writing this out? Actually, no, now that I actually try to write it out, I was going to try to express the ABC triangle in terms of the smaller triangles inside it. It doesn't really work as cleanly as I thought. Yeah, do you someone link me, Jed? So I was going to try and get like some like cancellations here with like saying ABC is equal to like BMG plus GNC plus 2MNG and then look for some way to cancel things, but Utah is very... Oh, okay. If it's misleading, why bother? The idea that I had isn't really gonna work. I'm just gonna move on, I think. Hmm. Maybe let's take a little peek over the math Discord. I don't want to get too involved in anything, but let's at least see what's over there. Hmm. All right, someone else is already helping out with that one. B and B frames. This might be a different name for something that I know. Let's see. Let's look at it a bit more. Okay, consider the curve given by r of t is equal to t squared minus 2t, comma, negative 2t, comma, 1/4 t cubed for 0 less than t less than equal to 3. You show my work file upload to attach a scan/image of your written work. Determine the unit tangent, unit normal, and unit binormal vectors of r at t equals 2. Unit tangent, is that the gradient? I do remember, I think I remember learning this stuff. It's just been a minute. Let me Google it. Let me bring up their work. Unit tangent vector is this, r prime t over the magnitude of r prime t. Okay. Oh, duh, yeah, it wouldn't be, the gradient's for something completely different. Yeah, you just derive each of these individually. And whatever you get, you divide by the magnitude of those things. And that's your unit tangent. But they're saying that they're having trouble with simplifications. So for, wow, they make r's in a weird way. So their r prime of t is 2t minus 2, I agree with that. Minus 2, I agree with that. And 3/4 t squared, I agree with that. Now you need to find, oh, are we evaluating it at t equals 2? Okay. So yeah, they evaluate at t equals 2, and then I think they could have saved themselves some work and just directly plug in or found the magnitude of 2, negative 2, 3. It should give you the same answer though with what they did. Uh, 4 plus 4 is 8, plus 9 is 17. So root 17, good. So your unit tangent is this over here. That's where they wrote it. Where were there? I can find t of 2 easy. I'm trouble simplifying t of t, so I can derive it and find n of t. Okay, so let's find unit normal now. Or let's find the formula for unit normal, because I don't remember it. T prime, okay. Sure. It's this, yeah, that's a slight issue, isn't it? That is a bit of a beast. Does this simplify? Can I have a quartic? Oh God, I don't think it simplifies, does it? Three-fourths t squared squared. Ah, x. That does not have a very clear square root, does it? Oh god. You can still find the derivative, it's just a massive pain. The big quotient rule. Is there a better way to do this? I have a feeling that these examples are all going to be pretty nice. Oh yeah, sine and cosine just cancel. They become one, rather. Oh my god. Disgusting. This is what this person is going to have to do. Does it cancel? Like there's a 2t minus 2 up here, and there's a 2t minus 2 there. Doesn't really cancel though because of all the other terms. In the way that this does. Yeah, I think the person is stuck doing this ugly derivative. What's the binormal? I don't remember binormal. Cross product? Oh god. Does Paul give a more, like... Oh... Oh man, Paul does it with simpler ones? That's cheating. Do we have to... Well, okay, let's plug their... Does Wolfram Alpha do this for us? If I just give this exact input and I say unit tangent, is it going to know what I want? 1/4 t cubed. I guess not. Yeah, it's not going to work. Like, it could be worse. It's just kind of a pain. If you do it at a point, no, you still need to derive it. I don't know if it responded either, so. Hmm. It's kind of a big thing to just explain like this. God. Epsilon delta. Please no more. I'm giving up on epsilon delta for now until section 2 starts. Physics. Oh, they didn't even show the entire question, it seems like. If I did know the entire question, I'd have a hard time with it, so. Hmm. Um. All right, yeah. Feel bad for that person, but I don't see anything else that they can do. Hmm. Well, I'm sure I have nothing, no new DMs on Reddit. Okay, let's see what this is. Oh, no, did I miss the period? Oh, yeah, won't this be X over 4? No. It's because I would normally have this dip right there and then come up here. And okay. Glad that person corrected me. Oh, okay. So this is it's a parabola that's been rotated in 3D, I believe. If I'm remembering my three-dimensional graphs right. One is opening up, starting from the origin. The other one is starting from z equals 8 and opening down. So they make this weird, like, cocktail shaker shape. If I'm not mistaken. Oh, it's a cone. It's a paraboloid with no square root? Oh, yeah. Okay. Ignore what I just said. Well, or change what I just said it to be in terms of cones and not cocktail shaker. I don't know what this would be. It's not really important either. Oh, yeah, it looks kind of weird because I'm zoomed out. But yeah, we get two intersecting cones, basically. Um, so this is probably, I'm guessing cylindrical is what you want here. Yeah, cylindrical make this a lot easier. You don't even need to worry about their intersection. R to 8 minus R. R goes from 0. Oh, you do need to worry about their intersection. Yeah. And if this work is to be believed, yeah, our radius is going to be 0 to 2. What? Hmm. Let's get our triple integral. What is the integrand? So let's verify that. I think they said it's Z, DZDR. Or, oh no, they said it's R, and that's what I thought it was too. Let's make sure though. Okay, it is R. R. Yeah, ZR theta. So we want Z goes from the bottom cone, which in cylindrical is just R, up to the top cone, which is 8 minus R. R goes from 0 out to the... Ooh. Yeah, out to the intersection, which is 2. And theta goes from 0 to 2 pi because it's a complete 360 on the xy axis, xy plane. 64 pi over 3. Just what they actually, yeah, they also used Wolfram alpha. I think they're right. So, trying to think of something that I might have done wrong, but I think I agree with them. R goes from the origin to the intersection of the cones, 0 to 2, and theta all the way around the xy plane, so 0 to 2 pi, which is all what you have. Did the other student share the integral they set up? Hmm. Someone else supposed to respond to this one? I want to see how someone else might have phrased it. Okay, so they use the periodicity like argument. Sorry, I probably shouldn't be making that mouth sound on stream. It's kind of loud in the mic, but I'm trying to think about what I want to do here. I keep looking for questions. Do I want to try to go back to real analysis? I just feel a little bit stuck with everything about epsilon delta. Just at least read what the rest of these questions are. Ooh. Got to do this proof, that, oh gosh, okay. Yeah, just kind of read what the rest of these are. I'm probably not going to do them because I'm just feeling tired and stupid, which is a dangerous combination, but consider the function, or consider f of x equals, I don't know how you're supposed to like say that, but roof x. Takes an input x and outputs the next largest integer greater than x. Well, it's a little bit different from roof how I think of it, because if you give it an integer, it'll still give you the next integer. So if you give it 1, it'll give you 2. And the roof function will give you 1, as I understand it. Confirm that f of 3/4 is equal to 1, f of negative 2/5 is equal to negative 2, and f of pi is equal to 4. Okay. Let g of x equal roof 1 minus x squared. Calculate that limit. Yeah, I'm not going to try that. Actually, well, let's calculate, not prove. The limit's going to be 1. The actual value at 0 is going to be 0. No, it's going to be... Wait, no. It's shifted up by... No. I'm mentioning just for x squared. This is 1 minus x squared. It's probably shifted up by 1 facing down. And you take the next greatest integer. So the actual value is x equals 0 is 2 by this definition. But immediately outside of 2, it's going to be 1. Actually, so yeah, I mean, I'm finding 7 easier than the epsilon delta proofs. I think I just kind of verbally did 7, even though I didn't actually write anything down. But the value of the function is different from the limit of the function. Maybe I should write something down on it, and maybe I'll notice something more, but I'm getting lazy. So I don't know if you're allowed to just do the cancellation. Maybe not, but I don't want to prove a limit right now. So this is the classic sine x over x, limit as x goes to 0 is equal to 1. I've seen a proof of this before, and I remember it generally involves a concept like this, but I don't remember exactly how it goes. I think part A is your big hint, which is sine of x is less than x is less than tangent of x. Oh. How does figure 9.1 show that sine of x is less than x less than tangent x? Areas of triangles, and oh, there's even a hint down here. Areas of sect. Oh gosh, okay. Yeah, I think I'm too mentally tired to tackle even this part A right now. Shoot. Yeah, normally I'd like to stream until Zach starts up the real analysis, but I'm just feeling kind of tired today. Let's see, is there anyone else who's streaming that I could raid, and maybe they'll raid out to Zach if they so choose. Dan isn't on. I do see Actual Education. And he's definitely rated out to Zach. And even if not, it's completely his prerogative. Okay. So yeah, I'm gonna cut off the YouTube stream here. Thanks so much everyone who's been hanging out on YouTube. I appreciate you. I'll be back. My next YouTube stream will be on Thursday at the same time as today, which is 4.5 hours ago, whatever that is in your time zone. So thank you, YouTube, and I'll see you around. I highly encourage you tonight in an hour to check out the real analysis class from Zach, by the way. That also goes for everyone on Twitch here too. Come on, Nightbot, post it. Why is Nightbot so slow on YouTube? There it goes. Okay. All right, YouTube. I'll see you around.